Hi guys, an update of my circuit. Let me try to do this with one hand. There's a multimeter, right? 1.5 volt. Ignore the solar panel and the 1.5 volt battery there. The screwdriver. This goes to supply this main circuit board here. This lead here, this white lead here, is connected to an environmental plug with LED connected to nothing. Alright, so this is from the base of the NPN transistor. This is from the trigger coil, the top of the second trigger coil. This is the first trigger coil, the yellow. Right, this yellow here goes to an environmental plug, positive connected to the series of LEDs there, a negative connect to the series of the LED here. The green wire here is from the same wire, the environmental plug, connected to a transformer, open-ended here. Well, it's just a coil, not really a transformer, right? So we can see that this part of the circuit here is a single wire transmission. I want to show that you can put electricity as long as alternating current, you can transmit it on one wire. Right, we take note the green wire is actually connected to the yellow wire, so basically we have one wire. I'm extending that wire into a transformer. Why is this useful? We'll show later on. The green plug over here, let me just show you, is connected to a 1 milli Henry choke. You can see that the white of the second trigger coil over here, this is a trigger coil, this is a trigger coil. This second trigger coil is actually connected to this green lead. We haven't connected this open-ended, same coil as the other guy, back into the 1 milli Henry choke. Right now you can see that this LED is on. This LED is also on. You can see it's red. I have to adjust the angle a little bit. This LED here, well, maybe it's very dimly lit, but you know, it doesn't matter if it's not lit up. It's running right now. Over here you can see this. Let me just focus a little bit. This is on the 200 milli DC volts. So basically what am I measuring? I'm measuring about roughly 600 microamperes, Y amperes, or rather 600 micro volts, because this emitter is actually connected to a shunt. You can see before I apply my negative into the motherboard, or rather the circuit board, and my positive I have going into 3, not very accurate, but I put in parallel so that I hope that they will get 1, but they are not getting 1. So you can see this is actually connected to the, let me just get this in focus again. Right, you can see everything is connected basically across to measure the voltage of the shunt. So basically, if I were to, this is roughly about 600 microvolts. Let me just disconnect the power supply here to show you it doesn't work. If I were to connect this, right, the LED goes out, the single wire does not conduct. Well, the voltmeter doesn't show the 0.06 anymore. What I'm gonna do is I'm going to just, when I disconnect it, let me just change this to the ohm range. Don't know whether I can see this. Yeah, but I'm in the ohm range, right? And you can see it's about 1.3 ohms. 600 divided by 1.3, you can do your mathematics. If I take it as one smaller number, it's 600 microamps. So 600 millivolts, sorry, 600 microvolts divided by 1.3, or divided by 1 is 600 microamps. Let us go back to the millivolt range here. Let me just show you again. Right, millivolt range. Let me just connect this one back up here. Right, and we have the LED lighting up. We have 2 LEDs here. This one here, it's not lighted up. This is from the diode, LED diode into the base from the emitter to the base to protect the transistor of the NPN. Over here is my PNP 3906. Here is my first trigger coil, and this is what I call it, 50K. You can see, let me just zoom in for you. Right, it's a 50K. It's maxed out. No, it's not maxed out, so it's maxed out 50K. I'm going to turn this thing up a little bit. Once I turn this thing up, you can see that our dear circuit starts to blink. Right, the one wire also start to blink. I don't know whether you can see this here. Let me just show it to you. Right, it's starting to blink over that side. Is this guy blinking? No, it's not blinking. You can see that it's jumping 700, 600, 5. You know, every time when it blinks. Let me just put it down here. You can see, right? So, yeah, pulsing. If you have a battery and then you have a smoothing capacitor, you can actually take some blinking LEDs. Take note, this is 7 in series, so if 2.5 volts or 2 volts to get them to work, you have about 2 times 4, 2 times 7 is 14 volts here. Let's take it as about 14 to 20 volts, that range. Again, this is working off a single wire, just to show you it's really single wire. I take the transformer off, and you can see that it is still working. Right, it's the yellow wire connected to my trigger coil. When I take that off, I can't see anything down here, but you know, I'm not going to put it back again because I want to show you the effects of the transformer. It's really quite interesting. Alright, now what I'm going to do is I'm going to first of all, I'm going to just connect this here. Let me just show you. I don't know whether you can see. Right, I'm going to plug in this transformer here. So I'm going to just plug in this transformer here. Right, still blinking. Right, doesn't blink. Right, blinking. Yeah, 0.5, whatever it is. Right, let me just now you saw it was 0.6 for when this transformer was not connected. Now I'm just gonna connect this guy here. Let me get this properly. Right, when I connect this, the single wire works a little bit better. How do I show you better? Better in the sense that this one start connecting. If my current is strong enough, actually this also can light up on a single wire. So we have this LED being lit up, this guy, and this guy, and we still have volts jumping. So right now I'm going to cut the thing short. I'm going to max out the resistor so that we have the joule teeth fired up. Okay, so it's like a super joule teeth. You can see this guy. Yeah, probably is very weak, but we are getting a 0.05, sorry, 0.5. That means 500 microamperes when we connected up this coil. Let's just call it coil. Transformers too hard. You can see it's lit up when my frequency is when my resistor is set for max out 50K or 100K. Yep, it's 50K. Right, my light here, you can see it's very dim. It's 0.6, 0.06, yeah, 0.6. Right, but once I hook this thing up, back again. Alright, this is difficult to do with one hand. We have 100 microamperes shave. Actually it's divided by 1.3, so you can do your maths there. This guy doesn't seem to be light up. Maybe it's too little current. Right, and our friend here is still light up. Let me just show the last part of the video where I reduce this to 0 and start to go into blinking mode again. And the funny thing is, when I reduce to 0, it doesn't start into blinking mode. That's the fun part of it. Now imagine I touch, if I touch the base here, it's going to oscillate. I'm going to come and touch the power supply. Right? When I touch the power supply, it starts blinking. You know, starts blinking. I don't know whether you can see that. It starts blinking, and of course, when it starts blinking, this guy powers up. Sometimes he overshoots. 600 micro. The most I give it 1 milliamp, but I'm talking about a blinking down here, right? And of course, the funny thing is, if I touch this, I don't know whether you can see this, right? If I touch this, it fires up the joule tip because the base is now powered up. It goes into oscillation mode, right? And this is lit, and it goes into 700 microamperes. Because why is it 700 microamperes? Well, that's an interesting one. I don't know whether this thing has been maxed out. Oh, this has not been maxed out. Let me just max this out. It was turned clockwise. That means to say it was 2.2 mech plus 0. Now it's 2.2 mech plus 1 mech, and we have 500 back again. Light up. Right, and this is I think for 500 microamps this doesn't light up. Okay, the funny thing is, if I walk here and with my foot I touch this, I set it back into blinking mode. Right, this is very interesting. I touch this part here with my body, and I don't think I'm having that much capacitance. It goes into blinking mode. Right, it goes into blinking mode. Right, and again, if I were to touch, maybe I just touch, okay, the power supply here, nothing happens. Right, our dear friends are all blinking away. Right, but then if I touch this, this one comes on, and we're back into oscillation mode, and we're taking 0.5, 0.6. Yeah, maybe that's a little bit unstable. Perhaps when this thing is turned up, it goes into 0.5. I'm not sure right now, but 0.6, which is back to the case where if maybe I need to touch this guy. You see, when I touch a power supply, it goes into blinking mode. Just now I didn't. Until I make it into blinking mode, I can either touch this guy or that guy can set it into blinking mode. Right. And if I'll touch it again, I have to touch this. Okay, it's set into blinking mode. We are at that 0.5, 0.6. Maybe this guy, very hard to find out effect, because initially when I hooked this thing up by connecting the white crock lead into the green, into the blue lead directly to the green crock lead, it showed 0.6. 0.6 now is flickering between 0.5. There's some perhaps stray capacitance, but not bad. You look at it, LEDs at night, they will light up. One LED down here working of about 600 micro, divide by 1.3, half a millivolt, half a milliampere. Trying to find out the effect of the coils here. I thought they would transmit a little bit. There will be another experiment where I will join this white one directly over there and see what happens. The combination is humongous with regards to understanding how dielectric currents work. If I were to disconnect this Evermanco plug, right now I have an Evermanco plug. It's 0.5. We are non-blinking mode. Right, let me just show you that we have a high voltage, high frequency traveling down through my power supply here. right? I think you saw that, right? Touch any part of it. Right there, you see. Yeah, it's in blinking mode, mind you, so I need to wait for it. Oh, it comes on. 0.5 over here. No, sorry, it's not in blinking mode, my mistake. It's just that oh yes, it is blinking mode. I don't know whether you can see this. There's another layer of electricity traveling. Can you see that? No, I need to touch properly. Right, it is blinking. And I touched that. Wow, it blinks a lot. It's bright. It's really bright when I touch this.